Let's pick up here with using the unit circle to find these functions specifically on the unit circle. That's simply a matter of looking at the unit circle and sometimes moving around it a little bit. So cosine of 45 degrees, when you look at the unit circle, you're looking for 45 and you're looking for the x value. So it's simply square root of 2 over 2. For the sine of 5 pi over 6, simply find where 5 pi over 6 is on the unit circle and look for the y value. Here is 5 pi over 6 and the y value is 1/2. So we'll use 1/2. That's the sine of that angle or that point on the unit circle. For the tangent of 225, let's find 225. And the tangent is the x value, I meant the y value divided by the x value. So that means it's equal to negative square root of 2 over 2 divided by negative square root over 2 over 2, which is obviously that over that, they're the same, which is equal to a positive 1. For the tangent of 7 pi over 4, 7 pi over 4, I thought I lost it for a moment. 7 pi over 4 is way over here. That's almost 8 pi over 4, so it's getting close to 2 pi. So we're going to do the y value over the x value. So in this case it's negative, oops, good thing I stopped to look at 7 pi over 6. So 7 pi over 6 is over here. That makes a big difference, getting the denominator mixed up. 4 would have been this one, but here we're at 7 pi over 6. Negative 1/2 divided by negative root 3 over 2. Negative 1/2 divided by negative root 3 over 2. Well, the negatives just cancel out, and what you have is 1/2 divided by 3 over 2. Shortcut is if the two denominators are the same, they cross each other out. The reason why that happens mathematically is that you get 1/2 divided by that means times the reciprocal. So these 2's cancel out and you get 1 over the square root of 3. You're not allowed for an answer to be with a denominator like that, so you have to multiply top and bottom by the square root of 3. So your actual answer is the square root of 3 over 3. I think I should box these answers so that they become clearer which ones they are. So it's square root of 3 over 3 for the tangent of 7 pi over 6. For the sine of negative 450, you have to go around the other way. So what that means is on the unit circle, you go this way to go to 450, but it's a negative, so that means we have to go around once, 360, and another 90, so we get to this point. That's the same as 270 degrees. And the sine at 270 degrees, okay, let's come to it here, 270 degrees, the sine is the y value, so that's equal to negative 1. So this is a coterminal angle, and sometimes that's what you have to find. It's the same place on the unit circle as the first time around the circle. For 3 pi, same thing. We're going to look for the cotangent. So if I go 1 pi, 2 pi, 3 pi, I'm at 180 degrees. And the cotangent is the x over the y. Cotangent is negative 1 over 0. We cannot do that. That makes this an undefined. The answer for this then becomes undefined. So you don't even show that once you see it. If it had been the tangent, it would have been 0 over negative 1, and that would have been 0. But the cotangent is negative 1 over 0, the x over the y. Okay, now, these ones over here, please do yourself with your unit circle. And if you don't have it, look in the Dropbox or look in the scanned notes. This will be part of those scanned notes at the end of it, at the end of these papers. So do those yourself. Stop the video. I'll start talking in 5 seconds on the video time. Alright, so cosine of 150 degrees is negative root 3 over 2. The sine of 11 pi over 6 is negative 1/2. Tangent of 315 degrees is negative 1. Tangent of 5 pi over 3 is the square root of 3. Actually, that should be a negative there. Negative root 3, because that's in the fourth quadrant. Sine of 630 degrees would be a 1. That's going to bring you back to 90 degrees. The cosine of 7 pi, if you keep on going around, is going to get you right back to 180 degrees, the same as this one here. So that means it's undefined. Okay, now let's look at the next part of this section, which is about reference angles. A reference angle is measuring an angle, I'm going to say the angle measure to the closest x-axis. So let's look at two of them on here. Let's go to 210 degrees. This is 210 degrees. Right? So it gets you to here. The reference angle is the distance back to 180, or from 180 to that. So in particular from the x-axis to that. And since this is 180 and this is 210 degrees, the difference is 30. So I'll put a 30 degrees here. So the reference angle for 210 degrees is 30 degrees. Now let's say we were looking at 315 degrees here. That means all the way around here is 315. What is this reference angle? Well, from here up to 360, so since we're going to here, it's not considered a negative, it's just considered the distance, the difference between the two. So that's a difference of 45. So I would say the reference angle for 315 degrees is 45 degrees. Now that you understand that, let's come down here and let's do the same thing. Let's find the reference angles for this part here, and we'll say that this one is 118 degrees up to here. So that's 118 degrees. And this one over here is 334 degrees. And so you need that reference angle. So please find those reference angles. I will stop the video and figure them out, and then in about 5 seconds I'll start talking again, or for you that will be whenever you start the video again. So find the, I shouldn't say find, I should simply say the reference angle for 118 degrees is, we need this 180, we need to know this amount, so we can simply do 180 minus 118. If that was 120, it would be 60. So that means it's slightly, if this was 120, it's a little bit closer that way. So that means it's a 62 amount. So it's 62 degrees is how much this is here. Then for this one, the reference angle for 334 degrees is, well, we need this amount here. So that's going to be 360 going to 334 going to 360. That's a difference of 26 here. So that means this is 26 degrees. So it's 62 degrees and 26 degrees. Unintended for them to switch like that. Just a nice little addition to what I did with this problem. Okay, two more problems to do. One particular part type. So you are standing at a 26-degree angle from a 7-foot tree. How far away is that tree? Well, let's do a little diagram of that. Here's a 7-foot tree. Okay, I'm not sure it really looks like a tree, but no one is letting me teach math because I happen to be good at art, because otherwise I wouldn't be teaching math. So if that's 7 feet, you're standing about here. That's supposed to be a person standing here. Please don't be offended that that's supposed to be you. So we know this is 26 degrees. That's 7 feet. We need to know this distance, how far away you are. So this is where, in order to set up an equation to solve this, you need to remember SOH, CA, TOA. You can use the sine of 26 degrees if you know or want to know the opposite and the hypotenuse. You can use the cosine if you know and want to know the adjacent and the hypotenuse. You can use the tangent if you know and want to know the opposite and the adjacent. That's the one that seems to fit here because we know 2 of the 3 things, so we can solve for x. So I can say that the tangent of 26 degrees is equal to the opposite over the adjacent. So this is an equation that will help us solve it. That's a trigonometric equation. Now we'll multiply by the x to get x times the tangent of 26 degrees is equal to 7. We want the x by itself. So let's divide by the tangent of 26 degrees. These cancel out, and x is approximately equal to 14.352 feet. Now, you could say 14.4 feet. That would be mathematically correct and you'll get credit for it. But we don't usually walk around saying 14.4 feet for the distance. We would probably round that to just simply 14 feet. Okay? And I shouldn't say x because x was just made up by me here. I would say the distance is approximately 14 feet or 14.4 feet. That would not be wrong. So one of these two would be the best answer for that. Your turn now. You're standing at a 67-degree angle from a 10-foot tree. How far away is the tree? Go ahead and figure that out yourself. Turn off the video or stop it and come back to it when you're ready. I will start talking in about 5 seconds video time. Okay, I'm going to do a 10-foot tree. I'm not even going to try to do the branches this time. I'm going to say that we're standing over here and we have a 67-degree angle. Well, now that makes it look like this amount's going to be a lot larger, but 67 degrees is actually more like here. It would be more realistic if I were to do it like this and say that's 67 degrees, that's 10 feet. This would be x. So we know it should be a smaller amount than 10, or probably it's not going to be a much larger amount. Once you hit 45 degrees, which is right in the middle between 0 and 90, well, below 45 this will be longer. Greater than 45 this will be shorter. So it should be shorter here. We'll make that 67. Let's do this. 67 degrees. There, that's better. Well, for 67 degrees we have opposite and adjacent, which is tangent again. So we're going to say the tangent of 67 degrees is equal to the opposite over the adjacent. And again, x times the tangent of 67 equal to 10. Divide by tangent of 67 degrees. These cancel out. Do 10 over the tangent of 67 degrees in your calculator, and you get the number 4.24. So you would either say that the distance is approximately 4 feet or 4.2 feet. So you could do either one and be considered correct there. So that's one of the types of applications of trigonometric functions. So you have seen in this case, in part 1, let's go back to that. In part 1, how to find a trig function for an angle that is not on the unit circle, and a practice problem for that. On the unit circle, dealing with the quadrantal quadrantal angles, the 90-degree and similar angles, using the unit circle to find sine and cosine and the other trig functions for angles on the unit circle in particular. And then you looked at reference angles, so make sure you're comfortable with that term and you finding it whenever it comes up. And then this application of using one of the trig functions in order to solve a problem.